Hi, ladies and gentlemen. Uh, Good evening, and it's great to be here again in our meetup. And so the topic of this meetup is all about games and quantum computing. And the reason why we're having this is because we want to use this as the platform for our hackathon to be done in Cebu. And so I'm going to introduce the gentleman who's going to give us a demo of this game. So allow me to welcome Andrew Oconer, an accomplished professional with an impressive portfolio in robotics, mechatronics, and artificial intelligence. He began his career as a firmware software engineer in Japan, transitioning into AI engineer consultant role at Accenture. He's also a mentor in Escuelabs, okay, data science bootcamps, where he shares his knowledge with tech leaders of tomorrow. As a quantum computing enthusiast, AJ constantly seeks to stay ahead of the technological curve. And when he is not working, he expresses his love for music and anime, showcasing his diverse range of interests. Let's give a warm welcome to AJ. AJ, take it away.
Hi, thank you, Sir Bobby, for the very nice introduction. Again, good evening, everyone. So, are you excited to learn about QISKIT and QISKIT blocks? So, okay, let me just share my screen. Can you give me a thumbs up if you can see my screen? Okay, thank you. So, we're going to discuss about creating quantum circuits using QISKIT blocks. So first, I'll give you the overview for our agenda for today. So I'll introduce you some few quantum computing concepts, and then basic quantum gates, and then using Qiskit and Qiskit blocks. So first, I'll introduce you to some quantum computing. Let us see what's the difference between classical computing and quantum computing. So for classical, as we all know, maybe it's just using 0 and 1 or 1. So for quantum, they're using qubits. So it can be 0, 1, or both simultaneously. So for the data representation for classical, it uses binary code, which is a sequence of zeros and ones. As for quantum, it uses quantum states, which is using superposition. So I'll also give a quick discussion for superposition later. For classical computing, it uses logic gates and or and not, and it uses operations sequentially. So it relies on faster processors or parallel computing. But for quantum computing, it operates in parallel due to the principles of superposition and quantum entanglement. So as for error correction, for classical, it uses redundancy and error correcting codes. But for quantum, it requires different algorithms for quantum error correction techniques. So why do we why are we interested in quantum computers? So if you're familiar with the Moore's law, so it states that the number of transistors on computer chips doubles approximately every 2 years. So as you can see here in this graph, ever since the microchip was first introduced, it was exponentially growing, the transistor count. So there will come a time that we cannot make transistors any smaller. So that's why we started in researching and creating quantum computers. So what can quantum computers solve? So I'll be introducing some complex problems that quantum computers might solve. So here, if you see here in the right is Peter Shore. So he developed an algorithm using it's called the source algorithm. So in quantum computing, it can break in the future it can break RSA cryptography. So what is RSA? So it is a algorithm that is being used right now in our internet for our secure communication, for digital signatures, for public keys. So it says here, Shor's algorithm can factor an integer n into its prime factors in polynomial time, which means it can break RSA encryption quickly, even for a very large values of n. So as a result, RSA encrypted messages and digital signatures become very vulnerable to attacks by large scale. So here comes the caveat. It can only be done by large scale fault tolerant quantum computers. But right now, the quantum computers that we have isn't like that yet. So I think we only have like a few hundred or I think 1,000 qubits available right now, and it's not yet very fault tolerant to break the RSA. So I'll be introducing basic quantum gates and the specific quantum computing concepts that are together with the quantum gates. So first, the X gate. Basically, it's the same as a classical NOT gate, which is turns one from to zero or zero to one. So later in the QISKIT block demos, we can see how it operates. So next, the H gate. So it's also called the Hadamard gate, and it puts the qubit to superposition. So what is superposition? So you may be familiar with this one. It's called the Schrodinger's cat. So it can be alive or dead. It's same with superposition. So the value can be zero or one. It depends on when you measure it. So next, the C NOT gate. It's called as the controlled NOT gate. So here, if the control qubit C is in the state of zero, the target qubit remains unchanged. But if the if the control qubit is state one, the target qubit undergoes a NOT operation. So with this, it also comes with the principle of quantum entanglement. So making the qubits entangled with each other. So next, I would also like to introduce QISKIT. So QISKIT is an open source SDK developed by IDM for creating quantum circuits. It can also be used to run quantum programs on simulators or even real quantum computers. So QISKIT is also based on Python, and you can also run it in your laptop. You can use your laptop to control a real quantum computer. So here is the exciting part. What is QISKIT blocks? So it is created by IBM quantum developer Dr. James Weaver using IBM QISKIT and Minetest. So Minetest is an open source, kind of like Minecraft. So it's a game where you can learn to and teach about different quantum computing concepts, like learn about quantum gates, quantum circuits, superposition, entanglement, and many more. So what's good about QISKIT blocks is can be installed in Windows, Mac, or even in Android phones. So okay, let me show you the QISKIT blocks. So I can send the link of the installer to the chat. So you can also download it and you can play it with us. So QISKIT blocks. Let me just open QISKIT blocks. So this is QISKIT blocks. So once you're done installing, once you open the zip file and open QISKIT blocks inside the bin folder, you can create and download QISKIT blocks in Minetest. So assuming, let's say, I'll install the package, and then you can click the content tab and then browse online content. And then you can search here QISKIT blocks and then install. So it wasn't that hard. So also just a reminder for installing, the version that we're using is 5.2 for Mindtest. So once we're done installing the QISKIT blocks, we can start the game here, and we can create our world. For example, I'll name it QISKIT block demo. So the seed should be one, and then the map gen is flat. And then you create which environment you want to use. So here, QISKIT blocks, create. And then when it's created, you can just press play game. So let's just wait for it to load. So here, as you can see, it's very cute. Even kids will be interested in playing this game. Actually, when I was preparing for this talk, my 5-year-old daughter saw me playing this, and then she wanted to play. And then I spent maybe an hour playing it, and then when she came back to the room, she said like, "Oh, you're still playing that game?" And then I said, "Yeah, it's really fun." So, um, Biscuit Blocks is a really nice game. So if you can see here, read first. So you can see here the controls. So Biscuit Blocks is an there's also an escape room experience. So you can play this like as a normal game, which uses WASD for controls. Here, if you press escape, the button on your keyboard, you can see the controls for QISKIT blocks. So let's continue. And you can see here the different blocks that you can use to create quantum circuits. So there are um, X gates, H gates, Z gates. So for this demo, we're going to show you the functions for H gate, X gate, and C naught gate. So okay, I'll also show you this. Who here are also familiar with this? Who are Doctor Who fans? So there's a TARDIS here. We can go inside and walk here. So there are different portals. So as you can see, there's just room 1 and 2. So the other rooms are still under construction. So if we go here in room 1, you can see here the quantum circuit. So we first go here in the chest. If you press right click, what's nice about this one is there's also a guide in every level, in every room. There are hints for you to solve the puzzle. So first, let's see. It says, notice the blue liquid indicates 100%. So for quantum computing, I mentioned earlier, there a 0 or 1. So that's also for 0, 1 is you measure the probability. So let's check. I'm going to get the X gate, left click and drag it here in my bag. So if you hit it with the X gate using right click, if you see here the Q, if it turns gold, that means you've solved the puzzle. So here's the question here. You need to turn the 0 to 1. If you can see up here, that's the output that you need to do. So we've transformed 0 to 1 by using the X gate. So we can go to the next room. Next. You can get another X gate. Put it in our bag. So it says, so now you can see there are 2 qubits that are being used here. So the output that we need is 1, 0. So where do we need to put the X gate? Is it here? So we turn the 0 to 1. See the colors? So when you read this notation, the first qubit is from the left. So 0 and 1, the position. So we've solved that puzzle, and we can go to the next room. So we get the X gate. Then we can jump. To jump, you can use the space bar, climb the stairs. So as you can see, this game is very engaging, and it will be easy to get kids to play this. Because even me, I'm already an adult. I enjoy playing this, but it seems that my Minecraft skills isn't that good yet. So I fell off the ladder. Okay. So you see here, the state is 0, 1, 1. So we need to put two X gates to convert 0 to 1. Where? In the yellow one and the blue one. So here, here. So as you can see, the Q turned to gold. Okay, as an additional information, if you right click here, you can see this code snippet. So this is actually coded in QASM, the quantum assembly language. So you can copy this code and paste it into IBM Quantum Composer, which I'll also show later. So let's get to the room. Let's move to the other room. So this one, this level introduces the concept of superposition. So let's see, what kind of gates do we use? So H gate. So I mentioned before, H gate, if you put H gate to a qubit, it puts it into superposition. So let's try put it. So here, as you can see, it matches the output here. So this means that it's if you measure it, it's a 50% 0 and 50% 1. So can move to the next room. Now next, I think we're also going to use uh, H gate here and X gate. So let's see. We need to put H gate to put it into superposition and X gate here. So you may be wondering why we put X gate here instead of the other side. So let's try it. If we put X here and we put H here, what happens? So the one doesn't change phase. It's because X it operates in a different quadrant, or it's in the to 0 and 1. But if you put it into superposition, it's positive and negative. So if you use X gate here, it can be changed to 1. So you can explore QISKIT blocks and the concept of superposition using H gate and X gate. So let's see and try to solve the other puzzles. I think the next level, we also have, Z gate here. So if you're wondering what's the use for Z gate, you can also um, check here the instructions. And also in the first room that we went into, there are room explanations for the blocks that we use. So this one, let's see. If we put H gate here and Z gate, so it's similar ways. So there are different ways for a quantum state to change using X and Z gates. So if you use different combinations of those, you can get your desired output. So next, okay, so this one we have 3 qubits. Let's see. We need to output 001, 101. Let's see if this will work. Actually, I haven't solved all of the rooms here in this QISKIT blocks. So we can explore what we can by using this, just exploring, putting gates here, putting gates here. You can, you can improve your quantum intuition. So let's say, for example, we put all X, what would be the output? It's gonna be 111. But if we put H gate here, you can change the state. So if we put it here, if you notice, if we put a lot of H gates, it's gonna be divided into the superposition from 50% to 25%. So let's see. Let's try to put X key here. And then here, let me try. Oops, no. For 60%, we need it to put Hadamard gate. There we go. So you can see here for the X gate, it turns into one, and then the Hadamard gate splits into two superposition. So we solve the puzzle. Next, what's this gate? Oh, it's just for each gate. The puzzle is okay here. So I've showed you. We've seen earlier that when we put two Hadamard gates, it divides the probability into four. So we solve this one, and the next, this one. If you can see the sum notation, that means that you add H gate here. So let's try. So we put it 8 basis states there. So we solve the puzzle. So as you can see, you can explore different gates here and try to check what kind of state it will become. So the last one here is the C not gate. So if you can see, there's a new tool here, the control tool. So we can use that to simulate the control not gate. So let's check. This one needs to output this one. So maybe we can try to put X gate here. So control. And then if you put the control here, it changes. That means the S gate is converted to control not gate or control X gate. So let's see. Change to H. That's right. Let's try a different one. Maybe here. So the output is 0, 0, 1, 1. Maybe here. Let's oh, it didn't change. Just let's try to put it in the middle. Change. I think it's okay there. So as you can see, if you put the H gate here and then the control gate here, you can change the state of these two qubits to 0, 0 and then 1, 1. So that solves the puzzle for quantum entanglement. So these qubits are already entangled. So I think that's for the demo for QISKIT blocks. So let's try to move out of the portal here and go back here. So once you start playing with QISKIT blocks, I think it's nice that you explore each gates here to read about what kind of operations that it does. So there's a lot of gates that you can use. So okay, that's for the demo. Let me get back to my slides. So what next? So in playing QISKIT games, you can learn more about different quantum computing concepts. So we can also create more escape rooms in QISKIT blocks. So I'll send a link later. There's a guide made by Dr. Beaver on how to create more escape rooms. So there's also experiment with IBM Quantum Composer. So I can also show you this one. So remember the QISKIT, the quantum assembly language that we got in QISKIT here. We can copy those circuits assembly language. For example, this one. Let's try. We can copy this one and paste it here in our quantum composer. So I think I need to log in first, just to quantum ID. Here. So this is the IBM Quantum Composer. So in on the right side here, you can paste the OpenCasm code, and then it will convert it to the circuit similar to the one here. You can also have use different gates. So for example, you put H gate here. So it has a very nice interface because it's just drag and drop, and you can also see the state here. So they also have different tutorials here and also samples. So for example, here, if you want to learn about the Grover algorithm, you can see the circuit that can implement the Grover algorithm. So that's it for the IBM Quantum Composer. So next, you can also try other quantum games. So there's Quantum Odyssey, which is like you can learn quantum from concepts, but it's like a space inspired or space themed game. There's Quantum Flytrap. Quantum Flytrap is more of like a quantum using photonics, and Quantum Pong. So Quantum Pong was, I think, developed. It's developed by Junhei Kwong. In the last, I think, there's QISKIT Camp in 2020 where they had the hackathon that they created this new Quantum Pong. So we're excited. Quantum PH is excited for the hackathon that we're gonna be doing. So hopefully, when we learn more about quantum computing, we can also create our own quantum games. So that's for the presentation. Thank you, and stay curious and keep exploring. Thanks, everyone.
Okay, thank you, uh, AJ. So I have a question. Um, I'm not sure if you've already um, explored everything in the game, but is there a level in the game that you have to implement Grover's algorithm or Shor's algorithm?
I think for the Grover's algorithm, there's an open path here. Maybe I can share my screen again. I need to get out of this escape room. So if you get stuck in the escape room, you can jump in the portal and go back to TARDIS. So there's an open space here where you can try to create the Grover algorithm. So there's sets here at the
Wow.
back. So you can use different gates here. So um, as you can see before in the that like I showed you earlier here, you can create this circuit. You can copy this one and create it here in the QISKIT blocks. So you get the gates that you need. For example, S gate, E gate, what gates you need, H and Z gate. So and swap control Z. So you can get it here and try to replicate it using this. I'm not sure about the source algorithm, but maybe the Grover, or yeah, maybe you can also try to implement source algorithm here because right now the in the open source or in this version of Qiskit blocks, these ones are blank, so it's you can use it freely
Okay.
to simulate the algorithms that you have.
I have a particular Grover's algorithm problem, which I wanted the the players to solve. how do you think I can put my problem into this platform?
Oh, you mean like the escape room that
Oh,
they have to
okay.
solve it?
That's the escape room. Okay.
Yeah. We can since this mind test is open source, so we can update the code to add another escape room.
Hmm.
So let me just open that. Because there's also a guide from Dr. Weaver in his GitHub page. Here, creating escape room in QISKIT blocks. So if you want, we can implement that rover algorithm challenge.
Yes.
You can update the code here and maybe change this
Hmm.
room 3 to be the Grover algorithm.
That's really a nice programming exercise. So it's a good project for anyone here in our group, to learn about mind test and be able to create our own one quantum, what do you call that? Lock room?
Yeah, escape room,
Escape
escape
room?
one
Escape room?
quantum escape room.
Yeah.
Yes. So
Okay.
it's nice that because it's open source, that
Yeah.
it's easy. I don't want to say it's easy, but it's you can create your own algorithms here in Qiskit. And what's also nice about this because it's it's already gamified,
Yeah.
so we can get more younger audience. So in different countries, they're already introducing quantum computing concepts in as young as middle school students and high school students.
We should
So
really do that.
once we've introduced the Kiskit blocks or other Kiskit games here
Yeah.
in the Philippines, so
Yeah.
young Filipinos will also be engaged, and they will have this they will be enthusiastic and excited to learn about quantum computing.
So while I was looking at your game, when I was looking at you playing, um, I was thinking for the uninitiated, it would really seem very strange uh,
Hmm.
putting all of this, uh, gates. So probably there should be a like a you know we should teach them first about the gates before they even touch the Kisket blocks, right? Like if you want
Yeah.
to, I mean, I'm already talking about our Cebu hackathon.
Hmm.
If you want them to to use this for the hackathon,
Yeah.
we should really introduce them to these basic concepts before they even go into this game and play it, right?
Yes, I absolutely agree with that one. Because of course in this workshop right now it's time limited. So of course in our
Yeah,
hackathon we're going to explain the different gates that
yeah.
or different quantum gates or the functions of different quantum gates. What will be the behavior of qubits once we use the H gate, once we use the X gate. So yeah, I agree with that one, Sir Bobby.
Okay, so does anyone else anything to add or any question?
Let me check the chat.
Yeah, there's a question from Brian. How much does this game cost?
Oh, Qiskit
Oh,
blocks. It's absolutely free.
absolutely free.
Yeah, you can download it. We can give away the link here.
Hmm.
So Dr. James Weaver provided it here in his GitHub page.
Yeah.
So I didn't pay for anything when I downloaded it. So we can send it the link to our attendees or even in the chat,
Yes.
so you can download it. It's the GitHub page is it's really nice and it's easy to follow the installation instructions.
Yeah.
So basically, you just download the Mindtest 5.2, and then as I've shown earlier, you can just browse the online content in QISKIT blocks. Here,
Yeah.
check to look for QISKIT blocks.
I was actually trying to run it on my Mac, but there is no 5.2 version of a mind test. It's only for Windows.
Ah,
So yeah, so I was fortunately uh, Edison here. He let me borrow his Windows machine.
that's good. But there's also instruction here for Mac OS, but actually I haven't tried this yet because I have a Windows PC. So
I
maybe we
mean,
can
I tried that, didn't work.
yeah,
Yeah,
maybe because the version
yeah.
for this one
It
is
should
only
really be
for
5.2.
5.2.
Yeah,
Yeah. I mean, if you check the last update here in this repository, it's still it's last year maybe.
yeah,
So maybe it's because it's open source. Maybe we can tweak it well for our hackathon.
yes. So by the way, we are very fortunate to have uh, to have Jeff, uh, our partner in the hackathon, join us here. So Jeff, do you have any questions or any comments?
Hi, Sir Bob. Good evening. Uh, is my audio clear?
Yes.
Yes, yes.
Thanks, AJ, for the demo. Actually, I have tried Odyssey, and now that I've seen Qiskit Blocks, I think Qiskit Blocks is more engaging.
Hmm.
Um, and Odyssey is a bit confusing, at least for me. And I think my question is that will this be included in the pre-hackathon? What do you call this? Pre-hackathon activities, or Bob?
I think so. I think we should because for example, if someone if we don't tell them that the hackathon is about Qiskit blocks, um, some of the participants might not know how
Yes.
to play it. Even
Yes.
myself, I don't know how to play Minecraft.
Yes.
Yeah.
So probably this will be in the later part of the pre-hackathon activities,
Yes.
and
It should.
the earlier part will be more focused on what gates are available and what gates do,
Yeah.
and then they can translate that understanding into Qiskit blocks.
Yeah. Yeah. I think what we can do is play this game, and then uh, I mean, if we can play it in its entirety, finish it, and then from there we'll have an idea what are the what are the things that we need to teach the participants so that they can play this game successfully.
Yes. Tama. Yeah. So thanks, AJ, for the demo. It's my first time also seeing
Thank
Qiskit
you.
in action. Actually, Sir Bob has already introduced me to Cricket Blocks while we were in Baguio, but I haven't really tried running it.
Yeah.
And it's mine what's that? Mine test? Is that the
I,
required package?
Yes, it's the record because it's Qiskit blocks is built on the Mindtest platform.
Okay. Okay. Thank you. I think I haven't installed that yet. But I've already installed Qiskit Blocks. So I'll try it on the weekend maybe.
yeah.
Thank you.
Thank you.
So,
Anyone else has a question or
I saw a question here in the chat box. So they're asking if is Qiskit blocks a form of programming language? No, it's not. It's not a form of programming language. I think it's based on QISKIT. QISKIT is the SDK that is being used by IBM. They developed QISKIT. So and the back end QISKIT is used to create QISKIT blocks.
Thank you for that. Thank you for that question, Glenn Kitayan. Okay, anyone else? So Brian here as a comment, QISKIT blocks is specifically designed for Minetest so that it can be free. Minecraft is not free. The question from Javas. QISKIT is okay, it's already, yeah, it's already answered. Okay, I guess if there's nothing else, so yeah, so I'd like to thank you once again, AJ, for this giving us this opportunity to learn a new thing, playing QISKIT blocks, to learn about quantum gates, quantum computing. Yeah, so yeah, so for our viewers out there, thank you for attending. And so OneQuantum is also known as Quantum Computing Society of the Philippines. So we are here to make the Filipinos aware of quantum computing, and we are very fortunate that DOST ASTI with Jeff here is our partner in making that possible. So there are a lot of things that we can do with that partnership, and I'm really excited for that. And yeah, so once again, thank you for AJ, and special mention to our to Jabez Aison, who is responsible for streaming this event. Thank you very much, Jabez, and that's it, guys. So thank you.
Thank you. So don't forget to like and subscribe in our YouTube page.
Thank you. Thank you, guys. Okay, bye. Good night.
Thank you.